All right. Here we have our lesson on exponential growth. Let's go. Looking for my pen. Where did my pen go? I don't know where my pen went. I'm going to use this pen. Oh, there it went. Oh, yeah. So, when something grows exponentially, we're going to use this equation. And for this equation, we have three variables. A is going to be the initial amount. R is going to be the rate as a decimal. And T is going to be the time. So this is what I'm looking for when I read the story. So if I look at number one, the original value of an investment is $1,800. That's what A equals. The value has increased by 7% each year. That's going to be R. Now, if I write down 7%, I have to have the skill to change it to a decimal. So let me show you. There's a decimal after 7. And we move that decimal 2 to the left. So it becomes 0.07. So do you have the skill to change a percent to a decimal? Okay? And then time, if I keep reading, find the value of the investment after 15 years. Then I write down the formula. So T is 15. A is 1,800. 1 plus 0.07. And then the exponent is T, which is 15. Then I'm going to type that into Desmos. So go to Desmos, and we're going to type this in. So that's 1,800, 1 plus 0.07 to the exponent 15. And so the answer is about 4,000. So $4,966. About. All right. Number two. In 2002, there were 972 students enrolled. So that's the initial amount of students, 972. Since then, the number of students has increased at a rate of 1.5%. That's the rate. And again, we need to move that decimal 2 to the left. So if I move that decimal 2 to the left, it becomes 0.015. We need that skill, percent compared to a decimal. And then time, write a function to model a situation. Find the number of students enrolled in 2014. So they don't give me the time. I have to figure it out. What's the years between 2002 and 2014? So that's 12 years. Subtract the numbers. Now I'm going to use the formula. So F at 12 equals the original amount, 972, 1 plus the rate, growth rate, to the exponent 12. Now you're going to go to Desmos and use a calculator. All right, so I'm going to change these numbers. So this is now 972. This is 0.015. And then the exponent is 12. And they're students, so we're going to round to a whole number for sure, 1,162 students. All right, so that's growth. Decay means something's getting smaller. So this is getting smaller over time. This is getting larger over time. So similar formula. You'll see one difference between it. Instead of adding, we're subtracting when it's decaying. This represents the same thing. So the initial amount, the rate as a decimal, and T represents the time. All right, so an investment of $12,000, that's my original amount, is losing value at a rate of 4% each year. So I need to have that skill to change that to 0.04. And then find the value after 9 years. So that's what T equals. So I'm trying to be a good reader. I'm using the formula, this formula. So T again is 9. A is 12,000. The rate as a decimal, 0.04. And then to the exponent 9. And now I'm going to use Desmos to calculate it for me. So again, I'm just going to change this. So 12,000. The rate was subtract 0.04 and then 9 years. And then write down the answer. It's 8,310. Right there. All right, Mark bought a brand new car for $35,000. That's what A equals, the original amount, in 2008. If the car depreciates, loses value 8% each year. So I'm just going to write it as a decimal. So 8% is 0.08. Find the value in 2015. So I need to do a little bit of math. 2008 to 2015, that's 7 years. And then use the formula. And then once you put it into the formula, now type it into Desmos. So 35,000, 1 minus 0.08 to the exponent 7. So now the car is worth about $19,525 if I round. All right, turn the page. Here's a second formula we're going to use, compound interest. So it occurs when interest is calculated on both the principal and the accrued interest. So in other words, you calculate the interest and add it back into your account. Now you have a bigger amount, and then when you do interest again, it's on the larger amount, and you calculate it and add it back in, and so on. We have a formula for that. And then I'll describe what each one represents. So A, again, is the end amount, but P is what would be called the principal, but we can just, again, call it the beginning amount or the initial amount. R, again, is a rate as a decimal. N is the number of times compounding per year. And then T again is time. So this is a new one. How many times a year are you calculating interest and adding it back into your account? So Lar deposited 12,000. That's what P equals. Into an account that earns 8% interest. That's the rate as a decimal. How much money will she have in 5 years? That's T. If the interest is compounded quarterly. Now the word quarterly means 4 times a year. We get that idea of quarters, right? Split into 4 parts, or quarters. How many quarters make a dollar? So that's where 4 comes from. And then we use that formula. So we're going to start with 12,000. 1 plus 0.08 divided by n. And then the exponent is 4. That's n times the year, which is 5. So that's what I'm going to put into Desmos. So we start with 12,000. 1 plus 0.08 divided by 4. And then the exponent, and we type in 4 times 5, or 20. See, if I do that, it's not going to stay in the exponent. So I have to use parentheses, and then you can go 4 times 5. Or you can type in 20. So it's $17,831. All right, number 6. If the interest is compounded, Jack took out a 6-year loan for $25,000. So P is $25,000. The time is 6 years. And the interest is, as a decimal, is 0.045. By moving the decimal to the left. It's compounded monthly. So how many months are there in a year? So if it's compounded monthly, that means 12 times a year. And then use the formula. So 25,000, 1 plus 0.045 divided by 12 to the exponent 12 times 6. So again, we're just using that formula, plugging in the numbers, and then going to Desmos, and then calculating it. So 25,000, 1 plus R, 0.045, divided by 12 to the exponent 12 times 6. So I'm going to go 12 times 6. And it's 32,733. Beautiful. All right, number 7. An investment pays 3.9%. So that's 0.039. Compounded semi-annually. That means twice a year. If 4,000 is invested, that's the initial amount, $4,000. What will the balance be after 12 years? That's 12. And then we put it into the formula. So we start with 4,000, 1 plus 0.039 divided by 2 to the exponent 2 times 12. So we use that formula. Come back to Desmos. 4,000, 1 plus 0.039 divided by 2 to the exponent 2 times 12. So it's $6,358. Savings account offers 0.8%. Man, that move the decimal. That's 0.008 if you move the decimal. Deposited $300. How much will be there after 10 years? And it's compounded bi-monthly. That means twice a month. So if there's 12 months in a year, twice a month would be 24. And then calculate it, 300, 1 plus 0.008 divided by 24, 24 times 10. And then use Desmos. So 300, 1 plus 0.008 divided by 24 to the exponent 24 times 10. And you get $324. 325. You made $25. Pretty good. Number 9, last one here. Suppose you invest $750. That's my initial amount. 3%. That's my rate as a decimal. That's 0.03. Compounded weekly. Just so you know, there's 52 weeks in a year. Yep. How much will you get after 20 years? That's so T is 20. And then the formula. So we plug into the formula. And then get your answer. So let's put this into Desmos. So that's 750. 1 plus 0.03 divided by 52 to the exponent 52 times 20. So that is $1,366. All right, there you have it. Mr. G Math over and out. Now we get to do our homework. Till next time.